First topic is miscellaneous limits. We just learn how to calculate a bunch of limits from early on, and we can also use advanced techniques. At this point, if you want to solve this question, press pause. Here is the solution. Notice that the numerator we can factor out an x. So this is x. Then we have x minus 4. The denominator equally factors into x minus 4 and x plus 1. We can now cancel out the x minus 4 as it's not equal to 0. And we get limit as x goes to 4x over x plus 1. This is an easy limit. We just have 4 divided by 5. And the problem is done. Second problem. Limit as x goes to minus 2 of x plus 2 divided by x cubed plus 8. For this limit, observe that the denominator is a difference of cube powers. It is x cubed minus 2 cubed. This then can be factored as x minus 2 times x squared plus x times minus 2 plus minus 2 squared. Again, we can cancel out x plus 2. This is then limit as x goes to minus 2 of 1 divided by x squared minus 2x plus 4. Plugging minus 2 in, we obtain 1 divided by minus 2 squared minus 2 times minus 2 plus 2 squared, and this is simply 1 divided by 3 times minus 2 squared, or 1 over 12. Notice you can solve it much faster. Method 2. Notice that the limit we have at hand looks very reminiscent of the derivative. This is limit as x goes to minus 2 of 1 divided by x cubed plus 8 divided by x plus 2. And if you look at this expression, it is the quotient that represents the slope of the secant line. So this is limit as x goes to minus 2 or better said, simply 1 divided by the derivative of x cubed, where x is minus 2. This is simply 1 divided by 3x squared, where x is equal to minus 2. And that becomes 1 over 3 minus 2 squared. Again, we obtain the same result. Problem number 3. Limit as x goes to minus 4 of 1 over 4 plus 1 over x divided by 4 plus x. Now, again, if you look at this limit carefully, it is of the form f of x minus f of a over x minus a, where x approaches a. So again, you see that this is just a derivative. In this case, f of x is 1 over x, and a is minus 4. Therefore, limit as x goes to minus 4 of 1/4 plus 1 over x over 4 plus x simply equals the derivative of 1 over x at x equal to minus 4, which is the derivative of x to the minus 1, where x is equal to minus 4. This is simply x to the power of minus 2 with a negative, where x is minus 4, and this yields minus 1 over minus 4 squared, which is minus 1 over 16. Of course, this problem, although much more tedious, could be also solved algebraically. So if you take limit as x goes to minus 4 of 1/4 plus 1 over x over 4 plus x, we can just simply combine the fractions. Now, to combine those fractions, multiply this by x, and the 1 over x multiplied by 4. This gives x plus 4 divided by 4x divided by 4 plus x. This is then simply 1 over 4x times x plus 4 over 4 plus x. So the x plus 4 and 4 plus x cancel out, and you just get 1 over 4 times minus 4, which is minus 1 over 16. Question 4. Limit as x goes to 1, limit as t goes to 1, of t to the power of 4 minus 1 over t cubed minus 1. Again, there are several ways of solving it. Method 1. Well, remember that the difference of n powers, if you have x to the n minus a to the n, this will be simply always x minus a times x to the n minus 1 plus a x to the n minus 2. The x gave its powers one power at a time to a. The next term is a squared x to the n minus 3, and so on and so forth until we get to a n minus 1. The powers of each monomial here, of each monomial sum, adds up to n minus 1. So the power of a, in this case, is a to the 0, x is to the power of n minus 1. Here a is to the power of 1, x is to the power of n minus 2. The powers always add up to n minus 1. You see n minus 3 plus 2 is n minus 1. 1 plus n minus 2 is n minus 1. So using method 1, we just see that we factor the numerator and denominator by the method of factoring n powers. So we can say simply limit as t goes to 1 of t to the 4 minus 1 can be factored as t minus 1 times t to the power of 3 plus t to the power 2, 1 to the power of 1, plus t to the power of 1 plus t to the power of 0 times 1 to the power of 3. The denominator can be factored as t minus 1 times t squared plus t plus 1. We now can cancel the t minus 1. And what we get is 1 plus 1 plus 1 plus 1. There are 1, 2, 3, 4 ones. Divided by 1 plus 1 plus 1, which is 3 copies of 1. So the answer is, you can even leave it without a limit here. The answer is simply 4 over 3. Method 2. You can always observe that this limit is very much like the definition of the derivative. On the bottom, if you just had t minus 1, that would have been the derivative of t to the 4 minus 1. So in method 2, we just place in what we would have liked to see. So if we see here t to the 4th minus 1, and we see that t goes to 1, we would have liked to see here a t minus 1. Because now it's just the definition of the derivative of t to the power 4 at 1. Now in the denominator, I see t cubed minus 1. And I also divide it by t minus 1. In other words, the numerator and the denominator were multiplied by 1 over t minus 1. So looking at it this way, what we see is the numerator is the derivative with respect to t of t to the power of 4, where t is equal to 1. The denominator is the derivative of t cubed where t is equal to 1. So the answer here would have been 4t cubed, where t is 1, and here 3t squared, where t is 1. Again, what we get is 4 over 3. Limit as t goes to 0 of root of 1 plus t minus root of 1 minus t divided by t. Again, the thing that comes to mind is that this looks very much like the derivative of the root function. So method 1, we manipulate this expression to look like a derivative and then just use derivative shortcuts. So how do we do that? We see limit as t goes to 0 of root of 1 plus t. What we would have liked to see here is simply minus root of 1, because then this represents the derivative, for instead of h I'm using t, of the root function at 1. So I introduced something by wishful thinking, something that did not exist there. And of course, I have to right away cancel it so that I don't change the expression. Divided by t. So then we break it into two limits. So the first limit is that derivative limit, root 1 plus t minus root of 1 divided by t. And here we have minus root of 1 minus t minus root of 1 divided by t. This is also the form of the derivative where our h is minus t. So it's natural to change this to a plus and put a minus here. This way, what we have is the derivative with respect to t of the root function root of t, where t is equal to 1, plus the second expression is also the derivative of root of t, where t is equal to 1. So the answer is just the derivative of root of t times 2, where t is equal to 1. Now the derivative of root of t is 1 over 2 root t, and this extra 2 what we get is 1 over root of 1, which is just simply 1. If you don't follow method 1, you can try the standard approach by just algebra. So again, limit where t goes to 0, root of 1 plus t minus root of 1 minus t over t. What we can do is we can multiply by the conjugate. So we have root one plus t minus root 1 minus t multiplied by root of 1 plus t plus root 1 minus t divided by t root 1 plus t plus root 1 minus t. This thing is simply 1 plus t minus 1 minus t divided by t root 1 plus t plus root 1 minus t. The result is that we have here 2t. Numerator simplifies to just 2t. Denominator is t. Here we have 1 plus t plus root of 1 minus t. T's can cross out. And what you get is 2 divided by root 1 plus root 1. Here I pressed t, I pushed it to 0, so we have root 1 plus root 1. So altogether we have 2 over 2, and again, the result is 1.